So if you are on and you're at home, you're also doing that game code as well. All right, Olivia. I know through each of those answers. So what I'm going to do is share the toughest questions and share the answer page for us. So that being said, let's look through and go over each of those questions. So number one, the correct answer for number one was J. Number two is B. Number three is E. 4 was I. 5 was K. 6 was G. 7 was D. 8 was H. 9 L. 10 C. 11 F. And then the second 11, which is really 12, was A. So those of you that put F twice there, that's okay. You actually got it right because I had a typo. All right. So looking at that, looking at your answers, checking it now that maybe you know how to check it correctly, does anybody have any questions or any of those problems that you still don't know why it was the matching answer that it was? No? Okay. Well, then, if we are all good and we don't feel as though we need to go over that any further, then, oh, go ahead. Sure. Correct. It's the opening up or opening down that matters in this case. So if a graph opens up, then it means my A value is positive. If the graph opens down, then my A value is negative. So I am going to put up like exactly what I am talking about in terms of that problem. So if you look, where is my, all right, let's stop our share and let's put up the video. We're gonna spotlight me. Okay, so what I mean by that is I can quickly look at each of these problems. And if I look at problem number one, this is a positive in front. So I know when I'm picking one of my answers that it has to be an opens up. Number two is positive, therefore it's an opens up. Number three is negative. So when I'm looking at the answers, this one needs to have an opens down because that graph is reflected based on that negative in front. So something like number 2 that you were asking about, there's no h value, so my vertex is 0. The k value is the sign it is, so it's -1. So when I'm looking for my answers, I'm looking for a vertex of 0, -1. Yes, okay. 0, -1 opens up. So on the back side here, letter B is 0, -1 opens up. The second thing is none of the other vertexes matched that vertex, so I really didn't have any other choices. But like this, go ahead. So technically number 9, yes. And technically you're not wrong. However, yesterday in the video when I was explaining how to do this homework, letters A, C, D, F, like the equations went through with problems 7 to 12, and the vertex and opens up or down went through 1 through 6. So like if you read like the directions here, it says match each absolute value for 1 through 6 with the coordinate of its vertex. Match the function with its graph. So that's why on the back, I really could have even split this into 2 different groupings of letters. But yeah, like the functions had to go with the graphs and the vertex and openings had to go with the equations on the front. Yeah, sorry about that. I guess like reading the directions closely kind of affected your homework check as well. I would never blame you, Caleb. All right, so then the next thing we're going to look at is actually this worksheet in your packets. So since I already wrote on this one, I'm going to screen mirror it and then use the iPad to write digitally. But, you know, my pen is missing because that's just my luck. So go ahead and open your notes guides to that worksheet now. And we are going to begin looking at that. Like I said, what we're going to do is go through this review handout a little bit. And as we're going through it, we're going to go over like the basic information that go along with an absolute value. So y equals 2 absolute value x minus 4 minus 2. That comes from our general equation of an absolute value. Okay, so what that means is that's coming from that general equation. So A is 2, H is 4, and K is -2. From the general form, we can take out or take away from it key pieces of information. So one of the key pieces of information we get is called the vertex. The vertex is H, comma K. So in this case, our vertex is 4, -2. And we like to put the vertex in the middle of our table because we can then look at the table, find our symmetry, and plot our points. We also know that this point is plotted right here, and that because that point is our vertex, my graph is going to be symmetric about that point. So what that means is that any point to the left or right of my vertex has to be the same distance. We call this dashed red line the axis of symmetry. The equation for the axis of symmetry is always equal to h. So in this case, our equation is x equals 4 because h is 4. So now we know that the graph is symmetric about that point. We also know that this graph is changed in such a way that our slope is equal to 2. So the slope comes from the a value. The a value represents our slope, which is 2. And that 2 tells me that my graph is stretched. So what that means is this graph is going to be more narrow than its parent's function. So this graph is going to be more narrow than its parent function. So it's stretched, it's moved. That positive h tells me that it is moved to the right 4. And that negative 2 tells me it went down 2. So again, the graph is stretched right 4, down 2. So my slope always goes in the direction of the right. So when you would take your vertex, you always apply your slope to the right. So we're going to go up 2 and over 1 to the right. Now, because of the red axis of symmetry, we can also go up 2 and left 1 from the vertex. If this points 2 units to the right, then it's also 2 units to the left across the red line. This one is 3 to the right, so it's 3 to the left, 4 to the right, 4 to the left. And then we simply draw in our 2 lines. Because again, an absolute value function is really just a piecewise function split at its vertex with opposite slopes. Now, our table is like any other table. You're going to go from the vertex and you're going to go to points less than 4 and points greater than 4. So that's 3, 2, 1, 0. 5, 6, 7, and then I can't scroll down because it'll move all of my writing, but there would be an 8. Now you have 2 choices on how to fill in the f of x column. You can plug in 3 or 5 to the original function of f of x. So we're going to plug in each of those x values to our original function. So if I plug in the number 5, it's like saying 2, absolute value, 5 minus 4, absolute value, minus 2. So 5 minus 4 is 1, absolute value of 1 is 1, 1 times 2 is 2, 2 minus 2 is 0. And what you should notice is if you go to x is 5 on the graph, it's also plotted at the point 5, 0. The values I get in my table should match the values I get on my graph. It's almost like a safety net. You're checking one to the other. Plugging in 6, 6 minus 4 is 2, absolute value of 2 is 2, 2 times 2 is 4, 4 minus 2 is 2. Plugging in 7, 7 minus 4 is 3, 3 times 2 is 6, 6 minus 2 is 4. Now, because the graph is symmetric about the vertex, so again, here's my vertex, right? Because the graph has symmetry about that point, whatever happens to the right of those numbers will happen to the left. So these will also be 0, 2, 4. And if you plug in 0, you get 6. Same with if you plug in 8. Okay? Hopefully that helps create some clarity for you on that example. So what I want to do is I know you already filled in a page on your packets on the 2-7 Notes Day 1 that talked about standard form. But what I want to do real quick is kind of go back and reiterate all of those key pieces of information about the absolute value function in standard form. So if you don't have space or a room on your paper you're working on currently, you can go backwards in the notes packet to that page. It's at the bottom of the very first day of notes for this unit. But basically what we're going to do is talk about what each of these values do. So A kind of has two important parts to it. A represents your slope to the right. It also tells me the direction the graph is going to open. So a positive A and a negative A have different meaning. A positive A is going to open up, and this is considered the normal. A negative A opens down. If a graph opens down, then that graph is considered to be reflected. So a graph that opens down is considered to be reflected. So when I ask you for transformations, if the A value is negative, you need to tell me reflected. Now, the slope can be described in one of two ways. If the A value is a fraction between 0 and 1, then our graph is considered compressed. If the A value is greater than 1, then my graph is considered stretched. So a compressed graph is really wide. A stretched graph is really narrow. An A value that opens up will look like a normal V, and an A value that opens down will look like this. So again, those are key features of that graph you can get just by looking at A. We get some other key features looking at H. So in the formula, the negative is part of the equation, not part of the H. So a negative H is actually going to do the opposite of what we think. So when it's a negative H inside that absolute value, it's actually going to look like a positive. A negative H will move us to the left. A positive H will move us to the right, but inside the absolute value, it's going to be the opposite sign of what is in front of H. Again, kind of tricky. The K value is less tricky. A positive K is up, and a negative K is down. So those two make sense to exactly what you think they should be. So a positive H goes right, a negative H goes left. This piece of information right here, this little chart, is everything you need to know about graphing an absolute value. This is the winner. This is like, if you have to have a note card out while you're doing your homework, you're open to something, this is what I would be open to. Because this chart is everything that is important. So those of you that are watching, if you want to take a picture or you want to save this, I just saved it. I'll send it on Teams. That's the key piece of information. So what you're going to do with the remainder of class time, which I know is almost nothing, and into tomorrow, is you're going to finish the worksheet we started. So you're going to finish this worksheet down here. Every box gets information in it. You're going to do the matching, hopefully more successfully this time, on the back. And that's your homework for tonight. And then for tomorrow, you're going to do the 2-7 review. Both of those will be uploaded as a single assignment on Fusion by 7:30 Thursday morning. So the remainder of this worksheet, the back with the matching, and the 2-7 review in your packet are all due at 7:30 on Thursday morning. So again, hopefully everything is good for you. Hopefully, there are no questions for me. Have a wonderful day, and I will see you guys again soon.